Welcome, humans, and any celestial body else out there listening. This is Curious Minds, Infinite Answers. I'm your host, Courtney Christine Costco. This podcast, simply put, is a mix of human curiosity and how, with the help of AI technology, curious minds can get the answers we seek. Let's get mind-bending and plunge deep beneath the surface of our everyday thoughts. Let's begin.
What's up, everyone? Hope you had a great week. Hope you danced a little, felt a little loose, felt a little freer. Well, thank you for joining me this week. We are talking about the Kardashev Scale, humanity's future among the stars. I started learning about this a little while ago, and it piqued my interest so much so that I deep dived and decided to create a podcast episode out of it. So I hope you enjoy it. I hope you learned something. I hope maybe some of this is a refresher and we just continue to move in the direction that we as a human race know we should be moving in for the better. And with that, let's begin. Let me ask you this. How much do you know about energy? Not the energy it takes to get out of bed in the morning, or the energy you feel at a rockin' concert. I'm talking about real energy. The power that fuels everything. The kind that keeps your lights on, your phone charged, your car moving, essentially everything that keeps the earth spinning in this modern world. Most of us don't think about it. I mean, it's just a part of our everyday use, and it's invisible. Until it isn't. Until the power goes out, until the gas bill spikes, until a blackout leaves an entire city in the dark. We rely on energy for everything, yet barely understand the systems that control it. And here's the real kicker. We don't even use a fraction of what's possible. Right now, we scrape together energy from fossil fuels, a little solar here, a little wind there, and it's barely enough to sustain us. But what if I told you we could be harnessing so much more? There's a scale. A way of measuring how advanced a civilization is based on its ability to control energy. Most people have never heard of it, unless they're deep into astrophysics or science fiction. It's called the Kardashev Scale. And it's not just a thought experiment. It's a roadmap for the future. A future where energy is limitless, travel between planets is normal, and civilization no longer fights over scraps, but instead builds wonders we can't even imagine. So today, we're going to pull back the curtain on what energy really means, how we're barely scratching the surface, and how, if we don't self-destruct first, we might just evolve into a species that truly harnesses the power of the universe. Before we get into the futuristic excitement of the Kardashev Scale, let's first talk about the energy crisis we're stuck in presently. Because let's be real, in the grand scheme of things, our energy game is kinda weak. As it stands, we're still digging fossilized plants and animals out of the ground, burning them, and acting like that's the best we can do. We literally set things on fire to power modern society. It's inefficient, dirty, and at the rate we're going, not even sustainable. And the worst part? Burning fossil fuels doesn't just waste energy, it's poisoning us. Every year, we pump billions of tons of carbon dioxide into the air, along with methane, sulfur dioxide, and nitrogen oxides, chemicals that don't just warm the planet, but choke the very air we breathe. Ever seen those satellite images of smog blanketing entire cities? Or perhaps, even worse yet, might you live in one? That's the direct result of our decisions to use outdated energy. Asthma rates are skyrocketing, cancer clusters are forming near refineries, ocean acidity is rising, and let's talk about our atmosphere. You know, the thing that's not just keeping us alive, but also defining what makes Earth, well, Earth. It's our planet's invisible shield, giving us the air we breathe, regulating temperature, and protecting us from deadly radiation and space debris. Without it, life as we know it wouldn't just struggle. It wouldn't exist at all. And we're over here tearing holes in it. Allow me to pause and zoom in on this before moving on. When people hear that we're tearing holes in our atmosphere, a lot of them assume it's just about burning fossil fuels. And yeah, that's a huge part of it, but it's not the whole story. And the only way we can do better is to first know how to. The way we're damaging our atmosphere is actually a combination of multiple human activities, and they each hit different layers in different ways. Let's start with one actual hole, the ozone layer. The ozone layer that sits in the stratosphere starts at around 9 to 18 miles or 15 to 30 kilometers above Earth's surface, depending on latitude. and it extends up to about 31 miles. Think of it like sunscreen for Earth, because it absorbs harmful UV radiation from the sun so we don't all fry and become dust in the wind. Okay, so let's get into how things started going really wrong. Back in the 20th century, we were dumping tons of CFGs, or chlorofluorocarbons, into the air. These were used in old-school aerosol sprays, refrigerants like Freon, pre-1990s, and industrial cleaning agents. These compounds were seen as safe, stable, and effective, until scientists discovered that they were destroying the ozone layer in the stratosphere. When these chemicals were released into the air, they slowly drifted up to the stratosphere. The CFCs broke down ozone molecules, thinning the layer and leading to the famous ozone hole over Antarctica. The more UV radiation that started coming through, the more skin cancer rates increased, the more ecosystems were destroyed, and the more weather patterns were disrupted. Good news? A little. We actually took action on this one. Thanks to the Montreal Protocol in 1987, CFGs were banned globally, and the ozone layer is slowly recovering. But that doesn't mean we're in the clear, because we're still wrecking the atmosphere in other ways. Greenhouse gases are trapping heat like an oven. The much bigger and ongoing issue here is how we're thickening parts of our atmosphere in the worst possible way. The more carbon dioxide, or CO2, methane, CH4, and nitrous oxide, N2O, we pump into the air, mostly from burning fossil fuels, agriculture, and industry, the more we turn our atmosphere into a heat-trapping blanket. This is what's causing global temperatures to rise, ice caps to melt, and weather patterns to go completely haywire. And here's what a lot of people don't realize. Carbon dioxide isn't the worst offender. There's also methane and nitrous oxide. Methane that comes from things like cattle farming, landfills, and natural gas leaks is actually 80 times more powerful at trapping heat over a short period. Nitrous oxide is released every time we burn fossil fuels, clear forests, or even just farm the wrong way. By pumping these gases into the air, we're essentially turning up the planet's thermostat. Then there's deforestation, killing Earth's natural air filters. So in addition to what's already been mentioned, we're also cutting down the very things that could be helping us fix this. Forests. Trees absorb CO2 and help regulate the atmosphere, but we're bulldozing them at insane rates for farming, urban expansion, and industry. Every acre of rainforest we destroy isn't just reducing biodiversity. It's reducing Earth's ability to regulate its own climate. And finally, there's industrial pollution and particulates, the air we breathe. The stuff we can actually see. Pollution from factories, wildfires, and vehicle emissions. These aren't just what we know as greenhouse gases, because there are also things like sulfur dioxide, SO2, and particulate matter, which cause acid rain, respiratory issues, and, no surprise, also messes with the climate. Fine particles from pollution can alter cloud formation, disrupt rain patterns, and even reduce sunlight reaching the surface in some areas. And because I like to break things down and really understand the content that isn't always common knowledge, I'm going to go ahead and do that with these questions. How is acid rain created? And where in the world has this happened? And could it happen to us here in the US? Okay, here's what we found. Acid rain forms when sulfur dioxide, SO2, and nitrogen oxide, NOx, are released into the atmosphere, mainly from burning fossil fuels, industrial processes, and vehicle emissions. These gases react with water vapor, oxygen, and other chemicals in the air, forming sulfuric acid, H2SO4, and nitric acid, HNO3. When this acidic mixture falls back to Earth as rain, snow, fog, or dust, it's known as acid precipitation, or simply acid rain. Now, acid rain won't burn your skin off like you've seen in cartoons and movies. It's not like touching battery acid. Acid rain typically has a pH between 4.0 and 4.5, which is similar to tomato juice or black coffee. Not strong enough to cause burns, but enough to still have severe effects on our environment, air quality, and building and monument erosion as it eats away at limestone, marble, and metal structures. While a single rainfall won't harm your skin, long-term exposure to acid fog or mist in highly polluted areas could irritate your eyes, lungs, and skin. If acid rain contaminates drinking water, it can cause health problems over time, like heavy metal exposure from dissolved minerals. So no, it won't burn you, but it's definitely not something we want more of in our environment. Okay, so where and when has acid rain been a problem? Here's what we found. Acid rain was a major environmental crisis in the mid to late 20th century. Europe experienced it from the 1970s to 1980s. Acid rain contributed to the destruction of forests in Germany's Black Forest and Scandinavia's lakes. China and India experienced acid rain starting in the 1990s and are still experiencing it to this day. In these regions, rapid industrialization led to major sulfur dioxide emissions, causing acid rain that damages farmland, rivers, and historical monuments like the Taj Mahal in India. Now, has this happened in the U.S.? The answer is yes, it has, but at lower levels than before. Thanks to stronger environmental regulations like the Clean Air Act Amendment of 1990, the U.S. has drastically reduced sulfur dioxide, or SO2, and nitrogen oxides, NOx, the main culprits behind acid rain. But, and this is a big but, if we were to loosen regulations, burn more coal, or ignore industrial pollution, acid rain could make a very serious comeback. Where exactly? Well, the Midwest and Appalachia, places like Ohio, Pennsylvania, and West Virginia, where they still have coal-burning power plants pumping out sulfur dioxide. And where does the pollution go? Straight into the air, drifting eastward, where it can mix seamlessly with water vapor and come down as acid rain. And here's the other thing. Just because we fixed some of our pollution doesn't mean we're immune from what's happening around the world. Air pollution doesn't respect borders. If countries like China and India continue pumping sulfur dioxide into the air, those pollutants can travel across the Pacific and impact our atmosphere too. So yeah, acid rain isn't an immediate crisis for most of us right now, but it could be if we stop paying attention. The fact that we reduced it before proves that we can fix environmental damage, but only if we stay on top of it. Moral of the story here, we're messing with our atmosphere on multiple levels. We've thinned the ozone layer. We've thickened the greenhouse layer to the point where it's trapping too much heat. We're destroying the natural systems that could absorb CO2, and we're filling the air with pollutants that cause acid rain and health issues. It's not just one thing. It's a perfect storm of bad decisions, short-term thinking, profits, and industrial habits that we need to break. Destabilizing the climate and creating conditions that make extreme weather more violent, unpredictable, and deadly is something we've got to get control over. Wildfires, floods, superstorms, they're not just freak occurrences anymore if you haven't noticed. They're warnings that we're pushing this planet to its breaking point. And let me be very clear at just how delicate of a situation this is. Our breathable atmosphere extends roughly 5 to 8 miles above Earth's surface, which is where what's called the troposphere ends. The troposphere is the lowest layer of Earth's atmosphere. That's where all the weather happens and almost all breathable air exists. I think it was Neil deGrasse Tyson that once explained on his show Star Talk that the distance from the surface of Earth to the edge of our breathable air is like comparing that of the skin of an apple to its flesh. So where do we stand? What alternatives have we as humans tried in order to make things better? In short, we've tried solar power, which is better, but we need better storage solutions. We've tried wind energy, useful but inconsistent. Hydroelectric, reliable but limited by geography. Nuclear fission, powerful but controversial and waste-heavy. Fusion power, what most consider the holy grail, but we haven't quite cracked it yet. We're basically still playing with training wheels when it comes to energy, and because of that, we're fighting wars over oil. Entire economies depend on energy monopolies, and millions of people live in energy poverty. So the real question is, how do we break out of this outdated system? And that's where the Kardashev Scale comes in. All right, now that we have a clearer understanding of where we've come from and where we are concerning energy resources, let's talk about what the Kardashev Scale actually is. In 1964, Soviet astrophysicist Nikolai Kardashev asked a simple but profound question. How advanced can a civilization really get? And instead of measuring progress by technology or space travel, he measured it by energy control. He talked about there being 3 types of civilizations. Type 1, planetary civilization. This is where we would harness all the energy available on Earth. That means mastering solar, wind, geothermal, and even tapping into things like controlled nuclear fission. A Type 1 civilization doesn't worry about energy shortages. It has full control over the planet's power. A Type 1 future would be considered about 100 to 200 years away if we make it. And if we do, we could look forward to no energy shortages, no fossil fuels, and no pollution. Maglev trains that cross continents in hours. Smart cities powered by unlimited clean energy. Global cooperation because energy is no longer a source of conflict. Type 2, stellar civilization. Now, this is where things get sci-fi, but not out of the realm of possibility, especially at the rate in which quantum technology is moving right now. A Type 2 civilization doesn't just use the energy of its planet, it uses the entire energy of its star. Imagine a massive Dyson sphere, a structure surrounding the sun, capturing its full power. Unlimited energy, making interstellar travel possible. No more energy scarcity, ever. A Type 2 future where humanity spreads across our solar system, where space travel becomes routine, and where medicine and AI evolve so much that aging might become optional. This future lies around 1,000 years away, if we survive. In Type 3, galactic civilization. A Type 3 civilization controls energy at the scale of a galaxy. At this point, we'd be so advanced, we might not even be recognizable as human anymore. Maybe we'd be digital beings, or something entirely beyond what we can even imagine right now. Traveling through black holes, manipulating gravity, and having meetings or lunch dates with our next universe-over neighbors. Pretty wild to think about. And the optimistic timeline? Around 5,000 years. And there's a conservative timeline around 100,000 to 1 million years. And I suppose I should probably mention the we might never make it theory. Some scientists argue that most civilizations never reach Type 3 because of the Great Filter. This is a hypothetical barrier that wipes out civilizations before they become interstellar. For example, resource depletion, war, AI takeover, or cosmic disasters. There's what's called the Fermi paradox, and it suggests that if Type 3 civilizations were common, we should have already seen evidence of them. But we don't. At least not with the technology we have today. So what's holding us back? If the future is this incredible, why aren't we there yet? Well, let's just touch on the things that make the world go round. Conspiracy theories. Specifically, conspiracies around energy suppression. There's Nikola Tesla's free energy idea, where many believe big corporations killed it, and potentially him. Cold fusion. Was it real? And suppressed? Oil and gas interests. Are we intentionally kept at Type 0 out of the 3 scales that Kardashev talks about? Okay, I'm not going to dig deep into all these conspiracy theories, but if you're interested, I highly recommend a documentary that I just stumbled upon recently called The Lost Century and How to Reclaim It. It's by Dr. Stephen Greer, and it exposes the cost of the cover-up to the planet and the human race, and how we can reclaim control of our collective destiny. And consider this, even if they are just conspiracy theories, there's always a little truth tucked neatly between the lines, if you look close enough. The bottom line is, humanity has a choice: evolve or self-destruct. Right now, we're teetering on the edge, but the Kardashev Scale shows us that if we get it together, our future is limitless. I digress. So, after everything we've talked about today, the Kardashev Scale, harnessing the power of the sun, mastering energy, and expanding beyond Earth, you might be wondering, will we actually make it to a Type 1, 2, or 3? Will humans one day spread across the Milky Way, controlling energy at the scale of entire star systems? Or are we doomed to destroy ourselves before we ever get the chance? The truth? No one knows. Some predictions say it could take just 5,000 years, a blink of an eye in cosmic time, if we move fast enough with AI, fusion energy, and space travel. Others think it could take hundreds of thousands, maybe even 1 million years, slowly expanding beyond our solar system. And then there's the darker theory that we might never make it at all. Because here's the thing, most civilizations might never make it past Type 0. And maybe that's why we don't see any Type 3 civilizations out there. The so-called Great Filter wipes them out before they reach that point. War, resource depletion, AI gone rogue, a disaster we don't see coming. It's possible that we're one bad decision away from being just another failed species in the universe's history. But maybe we're different. Maybe we recognize the dangers in time. Maybe we actually choose cooperation over destruction. Maybe we take our place among the stars, not as a civilization that burned out, but as one that broke through. One that harnessed the energy of the cosmos and survived. So the real question isn't how long will it take? The real question is, will we be wise enough to make it that far? And look, don't let the timeline scare you. After all, if we master the aging thing, then hey, see you there. Well, I'll keep digging, and I hope you do too. Because while we have a lot going on in our world, both exponentially and individually, and we may not take the time to think about things on this grand scale, or we may not think that our little individual parts will make a difference, I beg you to think again. I think that there is a chance that we individually can become part of a greater change. What do you think? Are we destined to reach Type 3? Or will we be our own downfall? Let me know your thought. And if you've enjoyed this episode, share it with a fellow curious mind. Because in the end, our future isn't written in the stars. It's written by us. Thanks for being here in this moment.
Thank you for tuning in to Curious Minds, Infinite Answers. I'm Courtney Christine Koskin, and I hope you'll join me for next week's episode as we proceed down the path of curiosity and discovery, uncovering various topics along the way. If you have any comments or want answers to your burning curiosities, drop me a line in the comments below. Until we meet again, find the good in the world, and if you can't find it, be the good.